So today we are looking at the angles formed with parallel lines and a transversal. All right, so first off, the little symbol on the lines that kind of looks like an arrow inside of the line instead of on the end, that is the marker to show that these lines are parallel. So these two lines are parallel. Same with over here. These two lines are parallel. And the line that crosses over both parallel lines, this is what we call a transversal. A transversal is just a line that crosses over two or more lines. All right? So when a transversal crosses over a pair of parallel lines, you'll notice it forms 8 angles. 1, 2, 3, 4, 5, 6, 7, 8. All right? And that's true of every set of parallel lines in a transversal. Okay? And there's a ton of relationships amongst these angles, but the main one is going to be this. The 4 angles up here, and I'll use my transparency to show you. So these 4 angles right here are exactly the same as these 4 angles down here. Boom. And you can kind of see that. And that's going to be true of every set of parallel lines in a transversal. Those angles are going to be exactly the same. I'll show you on this one. So these 4 angles at this little intersection right here will be the exact same angles as the angles at this intersection over here. So when you have a pair of parallel lines in a transversal, you really only need to find the angles around one little intersection, one little group of them, because the exact same angle measures over here are going to be the ones down here. All right? Now, let's show you how to find those angles. Let's say, for example, I knew that this angle right here was 120 degrees. All right. Just knowing that one angle, I can find all the rest of these angles. And here's how. So, starting with this straight line here, these 2 angles form a straight line, so they're supplementary. So they have to add up to 180 degrees. So this angle has to be 60. All right. Similarly, here's a straight line right here. So these 2 angles also have to be supplementary or add up to 180. So this also has to be 60 degrees. And down here is a straight line, so these 2 angles are supplementary. So they also add up to 180 degrees. So this has to be 120. So just like that, I found all 4 of these angles right here. Okay, these 4 angles here. Now, like I said before, once you find these 4 angles, you can find these 4 angles because they're going to be exactly the same. The 60, 120, the 60, and the 120. It's going to go right here. 60 degrees is going to match up with that one. 120 degrees matches up with this one. 60 degrees and 120 degrees because they're the exact same angles. So by just knowing one, I'm able to find all of the rest of the angles. All right? And that's true of any set of parallel lines in a transversal. I'll give you another example on this one. Let's say I know this angle right here. Let's say I know this angle is 80 degrees. Okay? Just knowing that, I can find all the angles here and all the angles here. Okay? So, just like before, this is a straight line. So these 2 angles here have to add up to 180. So this has to be 100. And here's another straight line here. So these 2 angles have to add up to 180. So this has to be 80 degrees. And here's another straight line right here. So these 2 angles are supplementary. So 80 plus 100 gets me 180. So I just found those 4 angles. And I'm going to repeat these 4 angles over here. 180 degrees. And 80 and 100 degrees. There we go. We got them all. All right. And notice there's only 2 different angle measures within this whole group. All right. Because they just get repeated over and over again. Now, the reason why that we know these angles are equal is there's an angle relationships among all of them. And there's actually a name for these angle relationships. And that's what I want to talk about next, because underneath here, I have a whole bunch of parallel lines and transversals and some of the key vocabulary terms. For example, vertical angles. When you have parallel lines in a transversal, actually when you have any 2 lines that intersect, vertical angles are the angles across from each other. For example, this angle right here is diagonally across from this angle right here. These are vertical angles. Vertical angles are congruent. These will always be the same angle measure. So whenever you have 2 lines that intersect, like for example here and here. When you have two lines that intersect and the angles formed across from each other are going to be equal. So they are vertical angles. And those aren't the only two pairs of vertical angles. We also have this angle right here and this angle right here. Those are vertical angles. And the last set of vertical angles are here and here. All right? So those are the four sets of vertical angles when we have parallel lines in a transversal. Now we also have things called corresponding angles. Those are the angles that have matching positions within their group. So we know about these two groups of angles, right? Well, the angle in the upper right-hand corner of its group has the same position as the angle that is in the top right-hand corner of this group down here. So these are called corresponding angles, and corresponding angles are always congruent, equal in measure. All right? So we could do it with any position. We could do the top left corner of this group and the top left corner of this group, and you can clearly see these angles are equal. All right? Here's the bottom right corner of this group up top and the bottom right corner of this group down below. Corresponding angles. And finally, bottom left corner of this group up here and bottom left corner of this group down here. Again, corresponding angles. So there's four pairs of corresponding angles. All right? Now, the last two vocabulary terms you need to know with parallel lines in a transversal are alternate exterior and alternate interior angles. And exterior means outside. In this case, we're talking about outside of the parallel lines. So here's my parallel lines. We're talking about the angles outside of them, not in between them, outside of them. For example, this angle right here is not between the parallel lines, so it's outside of the parallel lines. And we're talking about the alternate exterior angles, meaning they have to be outside because they're exterior, but alternate meaning on opposite sides of the transversal. So see how this angle here is on the outside but on the top left. This angle here is on the outside but on the bottom right. These are alternate exterior angles. Similarly, this one is on the outside on the top right. This angle right here is on the outside on the bottom left. These are alternate exterior angles, and those are equal in measure. All right? And very similarly, alternate interior angles this time, interior meaning inside, are the angles between the lines, but on opposite sides of the transversal. So for example, here's my transversal, here's my parallel lines. This angle right here is on the inside of the parallel lines because it's between the parallel lines, but it's in the top left. And this angle right here is in the bottom right between the lines. So these are alternate interior angles, and these are also equal in measure. And the last pair of alternate interior angles, top right between the lines and bottom left between the lines. All right, so these are your angle relationships and their names when we have parallel lines in a transversal. Notice, all of these angles I colored in here, these are all congruent. They're all equal in measure because of that relationship, that pattern we saw earlier, that the four angles up here match up to the four angles down there. All right, but each pair has a name. So hopefully this video helped you out a bit. If it did, please hit that like button. Also subscribe because it really helps us out. But with that being said, good luck on your math, and I will see you next time.